Hello learners, welcome to Let's Code. In the last lecture, we talked about problem solving and how to think before coding. Today, we will take the next step and understand something that every computer fundamentally works with, numbers. So before we jump into binary and bits, let's first understand what a number actually is. Okay, so let's take a very simple example. Let's say 573. All right. So let's say 573. How do you read this number? 573, right? But what does this number actually mean? When we were kids, we were taught something very interesting, place values. If you remember in mathematics, maybe in standard 3 or 4, I guess. Yeah. So at that time, we used to taught these things, how to represent a number and how to write it in expanded form. So let's try to do this, okay, today also. So given the number 573, how can we write it in expanded form? We can write like 500 plus 70 plus 3, right? Or we can also write like 5 into 10 to the power 2 plus 7 into 10 to the power 1 plus 3 into 10 to the power 0. And if we sum the things, it will become 573. Now, hopefully you guys know what we are doing here when we are writing 10 to the power 0. So just as a side note, any number to the power 0 equal to 1. It's not 0 or not infinity. I mean, this is already known to everyone, just to make a note. So this is how we can write this number 573, right? We spell it like 573. We don't realize it, but we have been using these power and bases since childhood. So if we here look carefully, what are we having for any number? First of all, we have base. So if we see in the expanded form, how we are representing this is, so let's say this thing, okay? This is called base. This is called symbol or digit. And this is nothing but power, okay? So if we write this down in plain English, what can we say? We can say that DSA is the number system we are using. And power position of the digit, like in which position this digit lies. Like this digit lies in the 0th position, 7 lies in the first position, and 5 lies in the second position. So power tells us the position of the digit, and then we have the value. So if we take this, this is the altogether value of this. This is the place value for this symbol or for this digit. So then we have the value, which means digit into base of power this. So this is how we are representing this decimal number. Okay. So in the decimal system, the base is 10. That's why every position is power of 10. But have you ever wondered why base 10? So there is simple history behind this. Before mathematics, people used to count using physical objects like fingers, stones, sticks, or bundles. Humans have 10 fingers, so grouping things in 10 become natural. So either we can have like single item, uh, two item, three item, four item, five item. So like 9 items, then we can have a bundle of 10. Again, when we have bundle of 10, then again we can have one item, two item, three item. Then again we can have another bundle of 10. Similarly, if we have 10 such bundle, we can have bundle of 100. So likewise, they used to group things together. So that's how decimal system was born. It's nothing special because it was convenient. Because we have 10 fingers and this was very convenient for human being to count using their hands. So if we have to say in plain English, in simple words, what is number system? We can say like number system is a way of grouping things. So in plain English, we can write like number system is a way of grouping things. Okay. So we just saw that number system exists because human group things. Decimal groups by 10. But decimal is not the only way to represent numbers. Once we understand grouping, we can understand any number system. So let's look at another number system, which is octal. So octal number system has a base of 8. So basically, what a base means, base represents the number of symbols any number system have or number of digits any number system have. So base represents the number of digits or symbol a number system can have. So what that means is, so let's say if we have decimal, it can have 10 symbols. That is 0 to 9. These are digits or symbols. Okay, like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. When it comes 10, that is just grouping and then again the starting from 0. Similarly, octal can have only 8 groups. That is 0 to 8. No, right? 7. And similarly, we have binary. So how many symbols can binary have? Bi means 2. So it can have maximum 2 symbols. So that is 0 and 1. Very similar to decimal, octal, binary, we also have hexadecimal. That can have 16 symbols. That is 0 to 9, then A, P, similarly till F. So 0 till 9 and then A till F. Okay, or let's write it like A till. Let's write it like A till. So 0 till 9 and then A till F. Okay. So this is what? This is the base of any number system. And what does the base do? Base tells us how many symbols or digits can a number system have. So in octal, you will never see symbols like 8, 9. Similarly, in binary, you will never see any symbols other than 0 and 1. In hexadecimal, you can see up to F, apart from 0 till 9, and you can also see A, B, C, D, E, F, but not anything else like G, H, I, J, K, L, not like that. Okay. So now since we are discussing octal, let's take any sample octal number. Okay. So let's say 345 or base 8. What is this? This is an octal number. So it can never have anything other than 0 to 7. Now, if we want to represent this octal number in decimal system, how will we do that? We will apply the same approach what we just did here. Here, what we did, we expanded it like the digit into base to the power of the position. Similarly, 7 into base to the power. Symbol, again 3 is the symbol and base is 10 and power position is 0. This thing, right? We will apply the same logic for the this octal number also, and we will try to convert it into decimal. Okay. So this rule never changes. The rule is like this. The rule is symbol or digit into base to the power or position, or let's say position. All right. So now let's try to apply this rule for octal and try to get the decimal number of it. So if we see, we have 3 here. So 3 into what is the base? Base is 8. What is the position? So if you start from position, starts from the right hand side. So it's the 0th position. This is the first position. This is the second position. So second plus, then we have 4 into base is 8. This is the first position plus 5 into base. This is the 0th position. If we try to calculate it, so 3 into 64 plus 4 into 8 plus 5 into as we learned before here, anything to the power 0 is always 1, right? So here also 8 to the power 0 is 1. So what this will become? 4, 3, 12, and 6, 3, 18, and 1, 19, plus 32, plus 5. This will become 2 to 4 and 5, 9, 9 plus 3, 12, 2 to 9. So this is the decimal representation of the octal number 345. So we did not memorize anything new. We just changed the base. If you understand decimal, you already understood octal and any other number system, right? So let's take this exact same approach and apply it to binary. So choose an example. Let's say we have a binary number 1011. Okay. So let's do the same here. Let's say we have a binary number. Let's say first. So let's have a simple binary number 1011. Now, if we want to convert this binary number to decimal, what we'll do? We will apply this same exact logic which we did for octal and decimal itself. Okay. So we can just write like 1, which is the symbol, into base. So what is base for binary? It's 2. So we will write 2, 2 to the power 0, 1, 2, 3. So 3 plus 0 into 2 to the power 2 plus 1 into 2 to the power 1 plus 1 into 2 to the power 0. Now, if we sum this up, so 2 to the power 3 is 8, and 8 into 1 is 8, plus 2 to the power 4 is 2 to the power 2 is 4, and 4 into 0 is 0, plus 2 to the power 1 is 2, and 1 into 2 is 2 itself. 2 to the power 0 is 1, and 1 into 1 is 1 itself. So what does this become? 8 plus 2, 10, 10 plus 1, 11. So this is the decimal representation of this binary number. Okay, I hope you guys understood this conversion. Now, did you notice something interesting? Whether it's be decimal, octal, binary, the steps never changed. What thing only changed? The base, right? Other than that, everything else was same. Entire step was same. So a number system is defined by two things: the base and the positional value, right? The base tells us the number of allowed digits or symbols, and the position value tells us the power of the base. Okay. So once this thing is clear, conversion becomes mechanical. It's become very simple. So now let's solve a very interesting problem that look simple, but actually tests how well you understand the number system. So let me just copy paste the problem statement in here. Okay. So the problem statement says, given a column title as it appears in Excel, return its column number. So this problem actually has been asked in interviews. In fact, it was asked to me also in one of my previous interviews. So the problem statement says, given a column title as it appears in Excel, return its column number. Okay. So in Excel, if you have noticed, the column numbers appears like this: A, B, C, D, and so on. Then it starts when AA, so it reaches to Z. Then it becomes AA, then AD, then again AZ, and when it reach AZ, it will start with BA, right? So this is how a column is, the column title is represented in Excel. So the problem statement is asking you to return the column number in decimal form, right? So A is 1, B is 2, 3, so on. Z will be 26. And then it will start with AA, which is 27. And similarly 28. Likewise. So I hope this problem makes sense to all of you guys. Now, how do we approach this problem? Did we learn anything today? If we think carefully, this is nothing but a number system conversion problem which we just did. Excel columns are not decimal, they are base 26 number, right? Like decimal has 10 base, octal has 8, binary has 2, hexadecimal has 16. Similarly, Excel columns have a base of 26. And what are the symbols for 26 base? This is A to Z. Now, in the question itself, it is given the column title consists only of uppercase English letters. This clears the doubt that the symbols will be A through Z in only uppercase English alphabet. Also, the constraint says the column title dot length can have from 1 to 7. So it can have like A, or like 7 is 1, 2, 3, 4, 5, 6, 7. Not any another place, right? Up to 7, like the string length will be 7 only. And column title is in the range of starting with A to maximum of F, X, S, H, whatever this string is, the maximum number that can this string hold. So that will be the maximum range. So these are the constraint. That means the column title can be stored in a integer, right? We have to return the column number, right? That is a number. So we can return the number as integer that can hold this largest number. That is why reading the constraints is important. Now, is there any abnormal thing you notice, any difference than any other number system? All the number systems which we have seen before, all the number system we just saw here, right here, the numbers or the symbols are starting from 0, 0 to 9, 0 to 7, 0 to 1. But here in this question, there is no 0. A is mapping to 1, Z is mapping to 26. So make sure you understand that difference. All right. But that difference will not make our approach to solve this problem or approach to the decimal conversion, which we did previously. It's very same and it will remain same. So if we compare with the decimal system, so let's say in decimal system, if we have a number 1, 2, 3, how did we convert it? Like how did we expand it? We write like 1 into 10 to the power 2 plus 2 into 10 to the power 1 plus 3 into 10 to the power 0. We will do the same if we had a number like AB, we will write like A, which is a symbol, into base. Now, what is the base here? We already discussed it, right? So the base here is 26. Why? Because it can consist only of uppercase English alphabet letter and the English alphabets are 26. So it will be 26 to the power 1 plus b into 26 to the power 0. Now, if we convert it, if we sum it, now we also have given what is meant by a. So a is 1. Here we write a is 1 and b is 2. So if we just place the values here, so 1 into 26 to the power 0 plus 2 into 26 to the power, sorry, here it was 1, not 0. 1 to 26 to the power 1 and 2 into 26 to the power 0. It will become 26 in times 1 equal to 26 into 1 equal to 26 plus this is anything to the power 0 is 1 into 2, which is nothing but 2. And this will become 28. So does this match our symbol? So here 27 is AA, 28 is AB. So if you see, our conversion logics fit exactly. No deviation from it, right? We need to just use the same conversion logic here also and try to solve this problem. So let's write the same conversion logic which we have already written here, somewhere here, I think. Yep, this one, right? Let's generalize this rule to any number system. So the generic rule is generic conversion rule. Number value equal to, we have to take the digit, first digit, and multiply it with the base. And what will be the power? So the power is the position of this number, right? So if we compare, like if we say in terms of the length of the number, so if it is 3 length number, power of the zeroth digit is nothing but n minus 1. Similarly, for it is n minus 2. So let's like the general formula like that only. In terms of n, it will be n minus 1 plus digit 1 into base to the power n minus 2, and so on, digit n minus 1 into base to the power 0, right? So this is the general formula for any number system to decimal conversion. We will apply the same formula here and we'll try to solve this problem. So let's clear this here. Yeah. Mhm. So this is the formula. Try to understand this. Now, before we jump into writing the solution, let's try to solve one more example with this, applying this formula once again. So let's say given any number in the Excel title like Z. So how will we apply? Once again, digit 0, which is Z, into base, which is 26, power is n minus 1. So 2, 2 minus 1, 1, plus digit 1, which is A, into base power n minus 2, which is 0. Now we map the values, the corresponding values for this symbol. So Z, if you see here, Z will be mapped to 26 and A is mapped to 1. So Z is 26 into 26 power 1 and this is 1 into 26 to the power 0. So what is 26 to the 26 into 26? This will be, so this part is always like 26 to the power 0 is 1 and 1 into 1 is 1. So what is this part? 26 into 26. So it will be 6 and so this will be 676. So if you sum this up, 677. So this will be the value, right? Now, this is just the conversion part, right? This is just the conversion part. We have to solve this problem. So in order to solve this problem, we will try to remember what we learned in our previous lecture and apply those steps. So step one was understanding the problem. We have understood the problem very well. Okay. We have thought of all the cases so far, and we have cleared out all the doubts. Now let's try to write the solution in step by step in plain English. So the solution will be, so we have to return the numeric value of the corresponding Excel title. So what do we have to return? An integer. So let's first define and result. So the step one is define result and initialize it with 0, right? So this is step one. Now, if we see what do we have in the formula to get the numeric value, digit into base to the power n minus 1 plus digit into base to the power n minus 2 and so on. So basically, for each of these symbols, we will need to multiply it with base, which we are already knowing, that is 26, and the power, which is the positional value, right? So what is n here? N is the length of the string, right? So we already know the length. So let's us also store the length, define result equal to 0, and also n equal to the, let's say, input. Let's say input is the value which is given to us, input dot length, right? Now, in the second step, what do we need? We need to traverse the input from left to right. What is the third step? Get the, like, for when you're traversing the input, so let's say the value is A, B, C, D. So this way we are traversing it. So we have to get each character out and map its integral value. So how we will get the integral value of each of the character? We'll just extract the character, okay, like this. And when we extract any character, the programming languages gives the ASCII value of this. Now, the ASCII value of capital A is 65, but you do not need to remember this. You can just do character minus the first character of English alphabet plus 1, which is 1. So A minus A is 0 plus 1 equal to 2. Similarly, for the B character, you need to do B minus A plus 1, which is 2. This is a clever way to get the mapping, right? Or if you don't know, if you don't know about this, if you know that the A is 65, You can also do a minus 64, it will be 1. Similarly, b minus 64, it will be 2. Similarly, c minus 64, it will be 3. You can do that also. Or if this is also seeming hard to you, or you don't know about this thing, you can just store each of the characters in a map, like a equal to 1, b equal to 2, c equal to 3, and you can retrieve it later while traversing. So the third step would be map each character to its integer value. Integer value or number value. What is the fourth step? You have to do result equal to the numeric value, uh, the numeric value, so let's write it clearly. The numeric value into base, which is 26 to the power n minus 1. So we already defined right here, n minus 1. We have to do this, right, in each of the steps. Now, if you see, we are doing n minus 1. So it might also reach, if you go to the input, it says the column title length could be up to 7. So can that just mean that we have to do 26 to the power 7? Here, if you see the input from 1 to 7, right? No, right? So it's not 26 to the power 7. We see we start the highest power is n minus 1. So if the maximum input length is 7, the highest power will be 26 to the power 6, right? Now this thing, this value is obviously not storable in an integer. So if we have to do this, this will become integer overflow and it will fail. But we can do 26 to the power 26, but the case is it will be multiplied with the numerical value, and the numerical value can also go up to 26. So again, if you do 26 to the power 26 and by into 26, it is again nothing but 22 to the power 7. So does this mean this will again overflow? Think about it. Because it is guaranteed that 26 to the power 7 is not possible to store in an integer. This is higher than the integer range. If you see the another constraint here, it says the column title is, the maximum range is this. So the problem statement knowingly has given you a value which is, so the first value could be f. So f is not 26, it is a b c d e f, it is 6. So 6 into 26 to the power 6. This is the maximum uh, first value which it can go up to. So basically this input, if you sum this entire input in this formula, it will become the int dot max. So the problem statement knowingly has given you this range so that it does not fall into the integer overflow. So if we just proceed with this formula, it will just work fine. But later, after learning more things, we will even be able to optimize this approach further. But as of now, since we don't know that, we will just stick to this approach only. Okay, so the fourth step was result equal to numeric value into 26 to the power n minus 1. That's what you have to do. And then append, sorry, it's not result equal to, it's result equal to this plus the existing result. Okay. We have to update the result each time. And then the sixth value is, sorry, the fifth step is return the result. Is this correct? Is this steps correct? Or do we any error so far? If you see here, I have written result equal to numerical value into 26 to the power n minus 1. This is not n minus 1, right? Is it constant always n minus 1? No, right? It's n minus 1, n minus 2. So we have to update. So it will not be n minus 1. It will be n minus I plus 1. So basically what this means is, since we are iterating in the loop, so initially I equal to 0, so I plus 1 is 1, so n minus 1. Then it will be first I equal to 1, so 1 plus 1 is 2, so n minus 2. So likewise, this will be n minus the iteration plus 1. So that is what it means. So yeah, that's how we have to approach this problem, and we have to solve this problem. I hope you understood this approach so far. This is exactly the same thing what we have been doing in examples. Just we have to do the same thing in code now. So once again, I will leave the coding part to you guys. I want you to solve this. This question is also available in Letz Code. Like if you want to solve it, please search this problem in Letz Code by exact this same title. I think you will be able to find this Excel column number. So you will get this problem in any online coding platform and try to solve this. This is an important question. Okay. So that is all for today's lesson. In the next lecture, we will learn about binary numbers, bitwise operations, and bit manipulation. In that lecture, we will learn how to even further optimize this approach, the same problem, with the help of something called shifting operators. That we will learn in the next lecture. For now, this is all. So thank you and see you in the next lecture.